Let us study the factors affecting the rate of chemical reactions. Here there are 5 factors which are affecting the rate of chemical reactions. The first one is known as nature of the reactants. Second one, size of the particles of reactants. Third one, concentration of reactants. Fourth one, temperature of the reaction. Fifth one, catalyst. First we will study nature of the reactants. Now the first example we are studying, that is nature of the reactants, how it is helping for taking place the reaction in a very quick way. So for that I am taking 2 test tubes. This is the first test tube, this is the second test tube. In one I am taking aluminium, in other I am taking zinc. Both of them are metals. Now in both of them I am pouring hydrochloric acid. Now both hydrochloric acids are dilute ones. You can find that as and when we pour hydrochloric acid, dilute hydrochloric acid in both the test tubes, immediately reaction starts. At the same time, reaction with the aluminium will be very quick. At the same time, reaction with the zinc will be very slow. From this we can understand that the reactivity level or the nature of aluminium is faster than zinc. Nature or reactivity same. So reactivity means the speed of reaction with the aluminium is faster than zinc. Why? Because the reactivity level of aluminium is more than zinc. Because of that, the reaction, we can say that with the aluminium is taking place in a very quick way compared to zinc. So here we can say that the reactivity of zinc is less than aluminium. So here we can say that nature of aluminium as well as zinc is different. Nature means the reactivity level. So here we can say that aluminium has more reactivity level compared to zinc. Because of that, reaction with aluminium is very fast. Now we will study about the size of the particles of reactants. Here we are taking Shahabad stone. For the second example we are taking Shahabad stone. Shahabad stone means a calcium carbonate. CaCO3, calcium carbonate. So Shahabad means is the name of a place. There this type of a stone, that means a calcium carbonate available in different forms. So Shahabad stone is specialized stone which is available in that particular region. So that stone has got the name as Shahabad stone. Now in that chemical component, that is calcium carbonate, is present. So we can say that Shahabad stone means a kind of calcium carbonate. Now here what is said, size of the particles of reactants affecting the rate of reaction. So you see here, again I am taking 2 test tubes. In one test tube I am taking pieces of Shahabad stone. In other I am taking powdered calcium carbonate, that is Shahabad stone or calcium carbonate. Chemical name is calcium carbonate, CaCO3. Now in one I taken powdered, other one I taken pieces of calcium carbonate or Shahabad stone. In both of them I am pouring dilute hydrochloric acid. Dilute hydrochloric acid. Here also I am pouring dilute hydrochloric acid. Now, you can find that both the place, here also calcium, here calcium carbonate is there, here pieces, here again calcium carbonate is there, but here powder. As and when we pour acid, that is dilute hydrochloric acid in both the test tubes, you can find that reaction takes place immediately. At the same time, here the reaction will be slow, as well as calcium carbonate pieces disappear very slowly. At the same time here, as a result of the reaction between powdered calcium carbonate as well as dilute hydrochloric acid, the powdered calcium carbonate disappear very quickly. Reaction takes place very fast and calcium carbonate, Shahabad stone powder, disappear very quickly. At the same time here, pieces are there, reaction takes place immediately. At the same time, these pieces slow by slow disappear. So we can say that if we are taking powdered reactant or reactants in the powdered form, reaction will be very fast, as well as disappearance of the powdered particles also very quickly will happen. So we can say that size of the particles affect the rate of chemical reaction. Here small powdered particles are there, because of that rate means the speed of the reaction took place in a very quick way. Now the third thing, that is concentration of the reactants. Concentration, that means we can say whether it is powerful or whether it is not powerful. We can say that one thing dilute, other one we can say concentrated. One is dilute, other one concentrated. Dilute hydrochloric acid, one. Other one concentrated hydrochloric acid. Concentrated, that means a very powerful. Here we can say it is less powerful. Dilute means a less powerful. Other one we can say more powerful. So here now we are studying about which one? Concentration of the reactants. For that I am taking now calcium carbonate only. That is, again I am taking in two test tubes powdered calcium carbonate. Both of them I am taking powdered calcium carbonate, CaCO3. Here again I am taking powdered calcium carbonate, CaCO3. Now in both, here we have to study that which one? Concentration of the reactants. So in one I am pouring dilute hydrochloric acid. In one test tube I am pouring dilute hydrochloric acid. In other I am pouring concentrated hydrochloric acid. So we can say that in this test tube I am pouring less powerful hydrochloric acid, but in this I am pouring more powerful concentrated hydrochloric acid. Because of that you can find that here now reaction in both the place, reaction starts immediately. As and when we pour dilute hydrochloric acid as well as concentrated hydrochloric acid into the powdered calcium carbonate, reaction takes place or reaction begins at once. Immediately reaction begins. But you can find that here reaction completes very quick way, very fast way. At the same time here reaction takes or reaction happens very slowly. Here reaction happens in a very quick way, very fast way, but here reaction takes in a very slow way. But immediately reaction begins. Both the place reaction begins at once. At once means immediately. But at the same time here reaction will be slowly, but here reaction will be quickly. So because of that we can say that concentration of the reactants affects the rate of chemical reaction. Here more concentration is there, more powerful acid is there, here less powerful acid is there. Now we are studying about the temperature of the reaction. Again with the help of diagram I will explain. Now here temperature of the reaction. So for that I am taking now one test tube with a bent tube. A test tube I taken which has a bent tube is there. Now this bent tube I am putting inside one test tube which contains lime water. Lime water. Lime water means calcium hydroxide solution. Calcium hydroxide solution. It has got one more name, that is slaked lime. Now here this calcium hydroxide solution has got one more name, that is in Hindi chuna solution, chuna water. Okay, so here we can say that lime water or chuna water we can see. Now, so here only plain water is there at present. Here I am taking now calcium carbonate, CaCO3. This thing, this bent test tube I am covering with a lid. It has no hole, holeless lid. Now here full of calcium carbonate I taken. Calcium carbonate, CaCO3. Now I am just heating this. Wire gauze is there. Now it's below. Fire supply I am doing. Fire supply. So here now one bent test tube I taken. Bent tube is there, such a test tube I taken. One side tube you can see, such a test tube. Now this tube has one end. Here I taken calcium carbonate. So calcium carbonate I am writing now outside. CaCO3. Here calcium carbonate taken. Now we have to heat it. As and when we heat this calcium carbonate, you can find that from that one gas is coming out. So I am showing that chemical reaction here, CaCO3. Just I am heating it. Here triangle sign is there, that is the sign of heat. As and when we heat it, calcium carbonate decomposes to calcium oxide plus carbon dioxide gas. This gas is coming into this calcium hydroxide solution or lime water. So here we can say that this calcium hydroxide as well as carbon dioxide reacts together, calcium carbonate will form. That calcium carbonate is having milky color. As a result of it, this lime water turns milky. The color of the lime water actually having plain water like color. Water has no color, same color only to the lime water. But as and when we pass carbon dioxide gas through this bent tube into the lime water turns milky. So we can say that for conversion of lime water to milky, requirement of heat is there. So we can say that here temperature of the reaction affects the rate of chemical reaction. So here for the reaction temperature is required. That temperature helps for the chemical reaction. So we can say that temperature affects the rate of chemical reaction. Now we are studying about what is catalyst. Catalyst means it is a substance whose presence helps the chemical reaction without undergoing any chemical change. So with example we will study. Here potassium chlorate, KClO3. Potassium chlorate, its name is potassium chlorate, CHLORATE. When we heat it converts to potassium chloride as well as oxygen. When potassium chloride we heat it, converts to potassium chloride as well as oxygen. Now I am writing it in the balanced form. So here K1, here also K1, Cl1, Cl1. But oxygen 3 here, here 2 is there. For equalizing both the side. Here now 1 here will be there 3. 2 if you are putting, then it will be 6. Here then for making it 6 we have to multiply it with the 3. So we can say that 2 KClO3 gives rise to KCl. Here now you see 2K. So I am putting here again 2. 2Cl. Here again 2Cl. Then 3 2s are 6. 3 2s are 6. When we heat it, potassium chlorate decomposes to potassium chloride as well as oxygen. But the reaction will be very slow. Now in other way, here now any size we can say either powdered form, either powdered or pieces form. Pieces of potassium chlorate, KClO3. If you are taking either powdered potassium chlorate or pieces of potassium chlorate, reaction's speed will be same when you heat it. Reaction will take place, potassium chlorate as well as oxygen will form, but at the same time reaction will be very slow if you are taking pieces of potassium chlorate or powdered potassium chlorate. But when you add a catalyst, that is MnO2, we can read it as manganese oxide. MnO2, manganese oxide. Only just we have to add. But this manganese dioxide, MnO2, manganese dioxide. It is not manganese oxide, manganese dioxide. Dioxygen 2, manganese dioxide. So here potassium chlorate, in that just we are adding manganese dioxide. As a result of it, potassium chlorate as well as 3 molecules of oxygen is forming in a very fast way or very quick way. So here we can say that this manganese dioxide does not undergo any chemical reaction. Only its mere presence is required. Only it is required here. Its presence is required. Just we have to put it. But there will be no chemical reaction between these two. You can find that as and when after adding this manganese dioxide and heating it, you can find that it decomposes. This potassium chlorate decomposes, breaks into potassium chloride as well as oxygen. I am drawing and showing you the diagram. Here I am taking potassium chlorate, KClO3. You can take it either in the form of powder or in the form of pieces. Here any, as you wish, you can take either in the form of pieces or in the form of powder. After that you have to heat it. You can find that reaction takes place. But that reaction will be very slow. But when you mix along with this manganese dioxide, just you have to add. So you can find that this remain as it is. We are just adding in it manganese dioxide. So because of its presence, reaction rate will be very fast. As a result of it, production of oxygen gas will be very fast. catalysts affect the chemical reaction. For that, one more example we will study. That is, here we are taking hydrogen peroxide, H2O2, hydrogen peroxide. Hydrogen peroxide. This hydrogen peroxide in the nature slowly converts to water as well as oxygen. Now here hydrogen 2, here also hydrogen 2, oxygen 2, but here oxygen 3. So here if you are putting 2, oxygen's level 2 and 2, 4 will become. Here if you are putting oxygen's level 4 will be. Similarly hydrogen here 2 2s are 4, here 2 2s are 4. So this is simple way of a balancing work I done now. So here now hydrogen peroxide slowly converts to water as well as oxygen in the nature. But when we add manganese dioxide, MnO2, it is a catalyst. So when we add manganese dioxide along with hydrogen peroxide, the reaction will be very, very fast. So we can say that here again manganese dioxide is acting as a catalyst. So from this we can understand catalysts affect the rate of chemical reaction. Here two examples we studied. One thing, potassium chlorate converts to potassium chloride as well as oxygen in a very quick way because of the presence of catalyst manganese dioxide. The second example, hydrogen peroxide transforms to water as well as oxygen because of the presence of manganese dioxide. This manganese dioxide as well as here manganese dioxide doesn't take part in the chemical reaction. Now we will study three important reactions. First one, what is oxidation? Second one, what is reduction? Third one, what is redox reaction? Now first we will study what is oxidation. Oxidation is a chemical reaction in which the reactant reacts with or combines with oxygen or it loses hydrogen to form a product. Then it is known as oxidation reaction. Here few examples of oxidation is written here. Here reactant side, this is the product side. Here reactant side, product side. Reactant side, product side. In between arrow mark is there. Now here you see these reactants, that is magnesium reacts with the oxygen or magnesium combines with oxygen to form a product. Then we can say that here combination with oxygen is taking place. Reaction with oxygen is taking place. So we can say this is an example of oxidation reaction. Here magnesium, Mg means magnesium, reacts with oxygen and forms magnesium oxide, MgO, magnesium oxide. Next one, carbon reacts with oxygen or carbon combines with oxygen to form a product, carbon dioxide. So we can say that here reaction with oxygen is taking place. Again it is an example of oxidation reaction. Here now, MgH2, magnesium hydride, magnesium hydride. From magnesium hydroxide, here magnesium hydroxide is the reactant. From that hydrogen removes. Then magnesium and hydrogen separates. Middle you can see a plus sign. So this is magnesium hydride. Magnesium hydride, MgH2. Here magnesium hydride decomposes to magnesium as well as hydrogen or magnesium hydride loses hydrogen, then we can say that again it is an example of oxidation reaction. Now here, this is CH3CH3. We can read it as ethane. CH3CH3. That is ethane. From each side, you see here CH3CH3 written, or we can write it as C2H6. Now from this ethane, 2 hydrogen removes. As a result of it, C2H4 as well as hydrogen gas is forming. Here CH2, CH2, that means C2H4. Here CH3, C2H6. So here now C2H6, that transforms to C2H4 along with that hydrogen. That means this ethane loses 2 hydrogen. Ethane, this is ethane. ETHANE, ethane loses 2 hydrogen. As a result of it, CH2 double bond CH2 became. So this compound we can read it as CH2 double bond CH2. We can read it as ethene, ETHENE, or we can read it as ethylene, ETHYLENE. So CH2 double bond CH2, we can read it as ethene or ethylene. Now CH3 single bond CH3, we can read it as ethane. Now here from ethane, 2 hydrogen atoms lost. As a result of it, CH2 double bond CH2 became. So here we can say that ethane loses 2 hydrogen for becoming ethene or ethylene. So again we can say this is an example of oxidation reaction. Now we are studying the examples of reduction. Now first we will study what is meant by reduction. Reduction is a reaction in which reactant loses oxygen or it combines with hydrogen. Then we can say that that is redox. That is reduction reaction. So once again, what is meant by reduction reaction? Reduction reaction is a reaction in which reactants loses oxygen or reacts with hydrogen. Now with example we will study. Here KClO3. This is the reactant. Now it loses, it breaks, it decomposes to KCl as well as oxygen. Here again balancing I have to do. Here 3 oxygen is there, so I am putting here now 2. So 2 3s are 6. Here I am making 6. 3 2s are 6. Then 2 KCl. So I am making here 2. So here we can say that potassium chloride decomposes to potassium chloride as well as oxygen. In this reaction you can see that from potassium chloride oxygen separates, oxygen goes away. You can see here potassium chloride as well as oxygen forms. From this reaction this oxygen goes away. Then we can say that this is an example of reduction reaction. Now we are studying about this. Here carbon dioxide is the reactant. From this carbon dioxide, oxygen as well as carbon separates. Oxygen goes away. Then carbon separates. So we can say that this is again an example of reduction reaction. Here CO2 in the combined form. But from that oxygen removes. Then carbon as well as oxygen separates. So we can say that this is again an example of reduction reaction. Now we are studying here. Carbon combines with hydrogen. C plus 2H2 forms CH4. CH4 we can read as methane. 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 Here carbon combines with hydrogen. 2H2. As a result of it, CH4 became. We can say here combination or combining or reaction of hydrogen with other element, then we can say that that is an example of reduction reaction. Here now, here this is ethene or ethylene compound, CH2 double bond CH2, that reacts with hydrogen, combine with hydrogen. As a result of it, ethane formed, ETHANE formed, CH3 single bond CH3 became. Here now you see CH2 double bond CH2. We can write it as, here I written CH2 double bond CH2, or we can write it as C2H4. This thing we can write in other way, that is C2H4. Now CH3 single bond CH3, that we can write as C2H6. So here now this place C2H4 transformed to C2H6. How? Because of combination of hydrogen with ethene or ethylene. As a result of it, ethane became. So here we can say combination or reaction with hydrogen. Then we can say this reaction as reduction reaction. Now we are coming to other reaction, that is known as redox reaction. What is meant by redox reaction? Redox reaction is a reaction in which oxidation as well as reduction takes place simultaneously. Simultaneously means at the same time both the reactions are taking place. That is reduction as well as oxidation. So we can say that a reaction. This is a reaction. This is a reaction. This is a reaction. This is a reaction. A reaction in which oxidation as well as reduction takes place simultaneously. Simultaneously means at the same time. Then we can say that this reaction is an example of redox reaction. 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 Let us see now. Here H2S, this is joining with the oxygen. H2S, in that oxygen is not there. This hydrogen, from H2S, sulfur goes. At the same time this hydrogen reacts with the oxygen. So we can say that this reaction is an example of oxidation. H2S, hydrogen sulfide, from that sulfur goes and this hydrogen reacts with the oxygen. Here oxygen is there, with that it reacts and water forms. So we can say this is an example of oxidation reaction. Now this oxygen reacted with the hydrogen. Now here sulfur is there, here sulfur is there. How many sulfur here? 2 sulfur and 1 sulfur. They separate. So we can say that this sulfur dioxide, this sulfur dioxide transforms to sulfur here. That means that from this sulfur dioxide, oxygen goes to hydrogen. From this sulfur dioxide, oxygen goes to hydrogen, and from this hydrogen sulfide, sulfur goes to sulfur dioxide. So here this oxygen goes away here and this sulfur goes to here. So we can say that sulfur transforms to here. From this sulfur dioxide, sulfur separates. Now here 1, here 2 sulfur, together now 3 sulfur became. Now 2H2 is there and here 2 oxygen is there, transforms to 2H2O. So we can say that here hydrogen transforms to water. That is an example of oxidation reaction. Here from this sulfur dioxide, sulfur goes away. Oxygen already reacted, now sulfur separated. So this reaction is known as a reduction reaction. So we can say that in a chemical reaction, oxidation as well as reduction takes place simultaneously. That means at the same time. Then we can say that this is an example of redox reaction. Now here, this is the second example. Here now CuO. From this CuO, O goes to here. Then water is forming and Cu separates. So I am writing here now, this Cu separates. From this CuO, oxygen goes to here. So we can say that here CuO transforms to Cu. This is an example of a reduction reaction. Means oxygen lost here. So we can say this is an example of reduction reaction. Now this hydrogen transforms to water. This hydrogen receives oxygen from this copper oxide and became water, H2O. So we can say that here oxygen is there. Then we can say this is an example of oxidation reaction. So here this is one chemical reaction. In the same chemical reaction, oxidation as well as reduction takes place at the same time. So we can say this is an example of redox reaction. Now here, barium sulfate, here O4 is there, oxygen is there. That goes to this place. So here we can say this oxygen goes to here, then carbon monoxide formed here. Carbon monoxide. CO2 will be there, then carbon dioxide. But here only one oxygen is there, one oxygen. Under oxygen nothing is there. So we can read it as carbon monoxide. Now barium sulfate transforms to barium sulfide. So we can say that here loss of oxygen took place. So this is an example of reduction reaction. Now here this carbon combined with the oxygen and formed carbon monoxide. So we can say that carbon combines with oxygen and became carbon monoxide. This is an example of oxidation reaction. Now when we compare this reaction, we can find that in this reaction itself, you can find two reactions, that is oxidation reaction as well as reduction reaction. So we can say that this reaction is an example of redox reaction. Now here, manganese dioxide transformed to, that means manganese oxide. This manganese reacts with the chlorine, this hydrogen reacts with the oxygen. As a result of it, these three compounds formed. Manganese chloride, then water as well as chlorine gas. Now we can say that from this manganese oxide, oxygen lost. So we can say that this is an example of reduction reaction. Here oxygen you cannot see. So we can say this is an example of reduction reaction. Now at the same time here, this hydrogen reacted with the water. So as a result of it, we can say that this hydrogen reacted with the oxygen and water became, so we can say this is an example. Here oxygen you are seeing. So we can say that this is an example of oxidation reaction. Now in this reaction, simultaneously oxidation as well as reduction reaction taken place. So this reaction is an example of redox reaction. What is rancidity? Rancidity is a chemical reaction which is taking place in the fried food items, or we can say that it is happening with the leftover oil or ghee. Actually we should not keep any oil after using. If you are keeping in open condition, immediately oxidation reaction will take place with the air. So if once we are frying any food items, the leftover oil we have to close it and keep. We should not allow oxygen to react with it. Even the food items after frying, we should not open and keep. The fried food items, we have to close it and keep in a container. That means we have to avoid the contact of fried food items or leftover oil with air. If it reacts with air, a foul odor will occur. As a result of it, the food items which are cooking further with the leftover oil, a bad smell will get to the food items, as well as it won't be good for consumption. Now, for protecting the leftover oil from oxidation, we can add some antioxidants in the oil, or we can put some antioxidants in the fried food items. Now, such a way we can be able to protect the food items from rancidity. Thank you.